Welcome to EDU World Space.
This is chapter 21, problem number 46. We're asked for a uniformly charged straight wire. We want to show that along the x-axis at a point, arbitrary point P, the electric field equals to lambda over 2 pi epsilon naught x L over L squared plus 4x squared to the power of half. So in order to prove this, we got to remember what the electric field is generated by a finite straight wire that has a linear charge density of lambda. So in order for that to resonate with you, I suggest that you revisit the example 21-11 because that's what on the textbook is done exactly. Deriving the electric field due to a uniformly charged straight wire. So what we're going to do here, we're just going to kind of switch the integration limits. They're going to be a little different. So let's get going. Imagine that this is the current carrying, wire, uniformly charged wire, no current yet. So we are at a point P, looking for the electric field, right? So if we pick an arbitrary infinitesimal piece of this charged straight wire, dy, so let's pick this distance to be y, and this wire extends from positive L over 2 to negative L over 2, and to the point that we're interested in, then the electric field is dE, right? And let's assume that this distance is r, and the distance in the x direction is a function of x, right? So now let's look at what this angle sees. So the sine theta would be equal to y over r being the hypotenuse, right? Let's write it in terms of x and y. Then it's going to be equal to x squared plus y squared square root of this, right? So for the maximum of this sine function, what we have is y equals L over 2, right? So sine theta then equals L over 2 over x squared plus L over 2 squared and square root of this. Now we can, again, please revisit 21-11. I'm skipping, obviously, a couple of steps here. So if we go to the evaluation part, then the electric field equals lambda over 4 pi epsilon naught x and sine theta. And we're going to evaluate this from the positive L over 2 over, write it here, over x squared plus L over 2 squared to the power of 1 over 2 and the negative part, right? X squared plus L over 2 squared, 1 over 2. Now, then this is going to be equal to lambda over 4 pi epsilon naught x, L over 2 over x squared plus L squared over 4, right? 1/2, this is a 2, minus negative L over 2 over x squared plus L squared over 4, 1/2, right? Now we have negative times negative, so it's going to give us positive lambda over 4 pi epsilon naught x, then equals L over x squared plus L squared over 4, 1/2. Now let's look at what we're trying to prove. What we're trying to prove for this term, it seems like every term here is multiplied by 4, and we're missing one, 2 here, right? So let's play with it a little bit. Let's write lambda over 2 pi epsilon naught x, and let's try to put this 2 inside this square root. If we do that, 2 pi epsilon naught x, if we do that, as you know, what we have is 4, right? Because square root of 4 gives us 2. So then 4x squared plus L squared over 4 times 4, which gives us L squared to the power of half. Well, that's it, right? This is the expression that we were looking for.